Hello everybody, welcome back. Today we're going to be looking at 7.2. We're going to finish up this section with example 3, solving a problem by writing then graphing a linear system. So the first thing, this one's a little more difficult because it doesn't give you the system. You have to come up with it. So this is just another strategy. Put some table together here and it says, what do we know? So it says to visit Head Smash in Buffalo Jump Center in Alberta. The admission is $5 for a student and $9 for an adult. In 1 hour, 32 people entered the building, and a total of $180 was an admission fees was collected. So we want to figure how many adults and how many students are going to be here. So first thing we do is we take our variables and we let them equal something. So in this case, we let S equal to students and A equal to the number of adults. We know that there's 32 people, so A plus S or S plus A is going to equal 32. $5 a student, so we use 5S for the variable, $9 an adult, so we'll take 9 times it by A. So the second equation is going to be 5S plus 9A is equal to 180, right? So I'll write those equations out. So S plus A is equal to 32. So S being the number of, like we talked about before, the number of students, and A being the number of adults. Okay? That's equation 1. Remember, name your equations. And then equation number 2, charge each adult, charge each student $5, so it's 5 times the number of students, and 9 for each adult times that, and then that's going to equal the total amount collected, which was 180. And there's your equations. So that's equation 2. Okay. So there's your system there. All right. And remember, we say let S equal the number of students and let A equal the number of adults. I know that was in the chart, but I just want to put that, write that out for you, okay? Oh. The whole thing will make red. Get rid of the bold. Doesn't do that big either. Alright. Okay. And that's it for the A part. And the B part, we want to solve the system using our graph rates. We want to figure out how many students, how many adults visit. So what we're going to do is I'll graph this with you. And I'm going to use the, you can use the x-intercept by, like I'm going to do it by hand with you. It's pretty straightforward. Just S plus A equals 32. That means that the x and y intercept, or the S and A intercept, are both going to be 32. So that will be on your graph. So we have, I go 6, see how your graph has going up there, so I'll make each block worth 2. So that'd be 10, 20, 30, or, yeah, that's what we'll do. So that'd be, so it's 32, so 10, 20, 30, 2 right there, right? So going up by 2s. And so I'll graph that. I'll do that with Desmos, showing you how to do that. So just exit our previous graph there. Start a new one. You can easily start a new one at Desmos.com. Right? So, like you said, we need to be 32. So, right? So there's your first graph, so 32 and 0 and 32, right? Okay. So there's your first line. S plus A equals to 32. There's your graph. All right. Now we're going to graph the second one. So to graph the second line is a little more difficult. Maybe you want to do like solve and make an equation, right? So you can take the 9 over and divide by 5, whatever the case may be. It's up to you. Or you can find the x and y intercepts again, right? I would probably do the x and y intercept method. So for the B part, I would take my equation and find the x and y intercepts, right? Okay, let's do that together here now. So we'll do it for both equations. Like I said, this one is pretty easy for here. For equation 1, the S intercept is 32, and the A intercept is also 32, right? graphed them before for you. And for this one here, we'll let s equals 0. So we'll solve for a. Right, so we let s equals 0, so plug 0 in there. And then left 9a is equal to 180. Divide both sides by 9. Right, divide both sides by 9. And then you get 20, right? So a is 20. So the a-intercept is 20. And then you'll do the same thing here. This time we're going to let a equal 0, right? There we go. So this time we let a equal 0. That's gone. We do 5s equals 180. 9 times 0 is gone. Divide both sides by 5. And when you divide both sides by 5, you get s equals, and 180 divided by 5 would obviously be 36, right? And there's the other intercept. So your s-intercept would be 36. So I don't know what you put on x and y. I'll just put x. I use my students on the x-axis, right, and my adults on the y-axis. Okay. So I'm going to use students here, adults here. So if I do that case here, students are here. All right. So that adult intercept would be 0 and 20, right, and the s-intercept would be 36 and 0. Okay. So if you want to just say that, okay, these are going to be x and y, right? Just for your graph, like just so you know those. And that's why I usually just do it right at the beginning. The book uses s and a, I'll use x and y. So obviously when we did the intercepts here for the b part, this means this s would be students, right? So it would be 32 and 0. And then this one here, 0 and 32 for the a-intercept. Because they're both the same, right? And then we'll graph these like we did start before. Okay? So I graphed the first one there, and then we'll do the second one with the intercept. So we got right, so there was that other intercept there. Alright. So we graph our 2 points right there. There's 0 and 20, 36 and 0. And then 32, 32, there's your 2 lines. And there's your intersection point at 25. It's 27 and 5. So that means it's just 27. You're going to have 27 students and 5 adults. Alright. Let's grab this for my graph. So you have it for your notes. You're doing this, you're not in class, right? There we are, there's your graph. Okay. And like I said, if you did it perfectly with your graph paper, and I'm going to do that with you on the board, it would be exactly at 27. So halfway between 26 and 28, and then exactly at 5, halfway between. You would see that, right? And again, that's an estimate, but I know it was 27 and 5 because they used the Desmos program, right? Okay. There's some homework to do with this as well. The homework is found on the page 409. So do the check your understanding number 3. That would be a couple pages back, maybe 407, 408. And then the questions there to go along with it. So that's it for 7.2. solving a system of equations by graphing. So I've showed you a number of ways you can do that, all right? And then next we're going to go do some more with the graphing calculator as well. All right, so thanks everybody for watching, and we'll talk again soon when we do 7.3 using graphic technology to solve linear equations.